Ladies and gentlemen, wow, that got a little bit of attention. Uh, Very, very, very welcome for those of you who made it, and for those of you who are trying to mill around and find a place or a spot at Green Tech that's meaningful. I think this is one is going to be that one. So my name is Theophilus van Rensburg Lindstrom. More details about myself or the entire panel can be achieved by simply scanning that quick response code. And that code is useful because it gives you access to all the information related to the session, the individuals that are participating, kind of function and roles that they have, but also the main theme and idea of this particular section. What's very crucial about this is that it enables you to also interact with the information that you get. You get to see the presentations afterwards and can help for sort of post-learning experiences. I speak about post-learning experiences rather because I'm a teacher, and I do believe that a little bit of thought and interaction after the fact is always useful. I'm simply the moderator, so my job is not to speak, although there are days that I love the sound of my own voice. Today it's not that. So we have three extraordinary panelists, and I would love for them to just introduce themselves at the beginning of each one of their sections so that when they start speaking, they can start off with a healthy introduction of themselves. The topic of today is an interesting one. I suppose that you chose it because it has some interest for you. But we would like to know if there are anyone in the audience that's a grower. Any farmers here? There's a grower. It's a grower in the house, yes. We do depend a lot on you. What about investors? Are there any folks who are looking for investment opportunities arising out of this session? I take that as a not yet. Okay. What about startups? Startup companies? No? Students? Business? Yeah, students there. Yeah, there are students. Business owners? No business owners? We have no business owners. We have no investors. We have a grower that keeps the whole thing together. The investors are still on the way in. But I hope that you're going to have questions wherever it comes from your angle. And so let me just remind you that what we're thinking here about is some keywords. Roadmap, that's a keyword. Strategic, that's another keyword. But to what? Talking about a sort of chemical-free or a residue-free crop. And so, Esme, I'm going to give over to you right away if you could introduce yourself.
Of course.
And in a way, you would be answering the question as to what are the key or fundamental issues or factors that we have to think about if we are going to create some kind of roadmap, so to speak, or a set of guidelines for a residue-free crop.
Yeah, we'll be happy to do that. So thank you very much. I'm Esme de Graaf. I'm a scientific researcher at Wageningen University, and I investigate plant resilience. So today I would like to tell you something about plant resilience in circular horticulture. And as the challenges that we face ahead, the importance of sustainable agriculture cannot be overstated. So I would like to shed some light on how we can enhance plant resilience within the framework of circular horticulture. So first I would like to tell you something about plant resilience and what it actually is. It's a natural defense system of the plant. When it's being attacked by pests or diseases, it already has its own immune system that can be activated. So in plants there are two main hormone pathways that are involved in this. One of the hormone pathways is the salicylic acid pathway, which is being activated when a plant is under attack of biotrophic pathogens, meaning pathogens that need a living organism to survive on. So you can think of fungi such as mildew or rust. But we also have the jasmonic acid pathway in plants, which is being activated when a plant is under attack of insects such as thrips or when it's under attack of necrotrophic pathogens like botrytis. But plant resilience, it can also be induced by us, for example. We have elicitors, which are analogs of hormones, and these can induce plant resilience as well. Also, microorganisms have an effect on plant resilience and can boost and activate the natural defense of the plant. Also, physical measures have a great influence on the plant resilience. So, plant resilience is under effect of a lot of different aspects. You can think of temperature, but also humidity, nutrients that are available for the plant, or the type of soil that you're growing your plant on. They all have an effect on the plant resilience, but also, because of that, on the resilient cropping system. So, it's turning and fine-tuning all of these aspects to have a whole resilient cropping system. So, resilient plants and getting resilient plants is often about preventive solution, such that when you have a strong plant from the beginning, it's not so affected by the disease or pest, and the chemical agents that we already have, it's much more curative. So you can think of the resilient cropping system, the prevention way. It starts with robust cultivars that already have some resilience and resistance against different pests or disease. But also optimal growing conditions chosen for this cultivar are needed, but also growing conditions that are unfavorable for the specific pest or disease. But also it's about hygiene and about conditions that slow down pests and diseases. But you can also think of stimulating biological control. Having a standing army in your greenhouse can help boost this resilient cropping system. So coming to circular horticulture, circular horticulture, you can think of the closed loop system, resource efficiency and minimal waste. It's the reuse of different products and closed loop systems. You will use maybe sometimes the same water you give to the plants, so nutrients will be in the water, so it will also have an effect on the fertilizers that you're using. So some critical components of circular horticulture that have that are needed for sustainable practices in agriculture can be water, plastics, fertilizers, growing media, CO2, and energy. And I would like to give you some examples on how they interact with plant resilience. So one example that I show you here is growing media and substrate resilience. Here you can see some Lysianthus plants that were infected with Fusarium. And when they had no treatment, as you can see in the red bar, almost 80% of the Lysianthus plant got infected with Fusarium. But when we added compost, which is a residual waste product of the mushroom cultivation, so the reuse of resources and products, when we added the compost, we saw more than half of the reduction of the amount of plants that got infected with Fusarium. So this has a big effect on the soil. But also beneficial microorganisms such as Bacillus, Amyloic vivacians, if we add them to the soil, we can see that it has a big effect on the reduction of disease and its suppression. Another example that I would like to give you is energy and plant resilience. A lot of growers nowadays, they switch from Sun-T to LED light. And LED light is very energy sufficient, but it also allows you to change color to any color type you like. So here we did the research on blackberries, where we added more blue light to the reference spectra. And when we looked to caterpillars that ate from the blackberry leaves, we saw a reduction of the damage caused by caterpillars, as you see in blue. But also phenol content was increased as compared to the reference. So you can see that adding blue light, so different ways of using your light strategy, can lead already to more increased plant resilience. A last example that I want to give you is nutrition on plant resilience. Here you can see a graph where we apply different concentrations of nitrate to the water of cherboas. And when you look to the lower concentrations of the nitrate, the 4 and 2 millimolar, we saw a reduction significantly on the powdery mildew that we found on the leaves. So what I want to tell you about plant resilience in circular horticulture, it's about the closed loop systems, the resource efficiency and minimal waste, but all these building blocks together, they make up a resilient cropping system. But also you can think of this integrated pest management, having a standing army in your greenhouse, that when plants are being attacked by aphids, for example, you already have some Oreos or ladybug beetles that are around in the greenhouse such that they can evade from a plague. So it's about minimizing environmental impact but maximizing productivity and resilience. It's really important, but it's also possible, and I think we should go to this place. And I hope I answered your question as before from this. So thank you for your attention. This was my presentation.
Great.
And I would
Thank you
pass the
so
floor.
much, Esme. Thank you.
You're welcome.
I mean, what is so wonderful here is just the focus of some real data sets that comes out. The word resilience comes up quite uh, repeatedly, and that's really what is key. And I hope you pick that up. If you have a question, if you could keep them for the last sort of section of the presentation, don't forget them. Write them down somewhere. And so we can come back to that. On the resilience side of it, I'm sure, Matthijs, you could connect easily to that. We talked about a good plant starting things off, but what's next after that? Matthijs, floor is yours.
Thank you very much, Theo, and thanks, Esme, for focusing really on plant resilience. I would like to, well, connect our stories by digging in on that standing army. This is actually what we do, and I, in actual fact, would like to challenge the topic of today, the theme, because we're talking about a strategic roadmap to residue-free crops, and I would rather focus on how can we make sure that we grow without chemical pesticides at all. In order to reach that, and we are not there yet, I won't be a wizard who can come up with most fantastic solutions straight away. I would like to take you along to show what we from Coppert are. I need a few minutes to explain, and then show what our vision is when it comes to that, well, I won't say residue-free crop, but trying to reach out to completely growing without any chemical pesticides. First of all, we believe that the world needs 100% sustainable agriculture. And with that, we contribute to the health of the people and the planet. Sounds great, but what do we actually do? And hopefully this visual will make that clear. This is what Coppert stands for. Coppert is focused at, we put the plant central, this is where one of our connections is, and we also cooperate closely with growers from all over the world. And we strongly believe once more that we can work towards a better world where hopefully somewhere, somehow, someday, pesticides, chemical pesticides will no longer be needed. And for that we need this in-depth knowledge, we need data-driven approaches, and I'm also curious what you think, what we need altogether on this roadmap. Coppert at a glance, without digging in, we are nowadays present in over 30 countries, about 3,000 colleagues worldwide, amongst our 400 plus advisors. So we are really a knowledge-driven organization. And we focus at three, when it comes to creating standing armies and creating biological alternatives over chemical pesticides, we offer mainly three different types of product groups, which are the macrobials, biological control on the left part, the natural pollination for natural, the bumblebee, sorry, for natural pollination. And we are focusing more and more also on microbials aimed at healthy soil, which is a mixture of microbials as well as beneficial nematodes. And our aim is pretty straightforward. Initially, we're aiming to reduce the chemical pesticide use by tenfold in the coming 10 years. With that offering, well, the products shown underneath, which I already mentioned. And it's not just why we do it, but why do we believe that it's necessary to do this? We see a number of changes. And a number of changes, global changes shown here, are maybe more than recognizable. 9 billion people somewhere, somehow, 70% living in cities. cities with more than 40 million people will no longer be an exception. We will have severe issues on water scarcity, soil depletion. We're losing out on biodiversity, and we need more and more than ever, safely sustainable produced food to feed all these 9 billion people. And it sounds cliche, maybe, the world is changing. So we have a number of challenges. We can't solve them all. We can't solve them by themselves. We need each other. And most probably, we need you without knowing, because you're not an investor and not a student and hardly a grower, who you are. But nevertheless, I'm really curious what your personal opinions are. So we are focusing on that soil depletion. We are working in basics on the food safety and the food security by providing these biological solutions. And why do we do this, and why do we see we have a kind of momentum? We have an increased demand. Most probably you will dig in and elaborate on the demand as such. But why do we foresee this? Because there is resistance against current chemical products. There were launched a report which shows which chemical pesticides will be faded out by law by 2030. And on one hand, we could say, hey, fantastic, because we can offer biological solution. Unfortunately, we don't have a biological solution for each and every product to be replaced yet. Next to that, you see an increased legislation. And last, but most definitely not least, public opinion. People are more and more demanding when it comes to a need for safe and sustainable produced food. And although partly in Dutch, some examples of what's going on within society as such. We see an importance and urgency, some pesticides no longer allowed. There was a lily grower who was too close to a housing area. And we see continuously these kind of examples popping up. And once again, this results in the fact that we need altogether provide alternatives for alternative solutions. And, sorry, didn't work for a second. What we believe in is that we have to come up with a complete new system, a kind of new ecosystem in actual fact, where we have to work together in a different way in which we do this today. Similar to what you showed in the symbolics of risk management versus control and kind of balancing, we believe that curative crop protection should shift to preventative crop protection, that pest control should be pest management in a controlled way throughout the year. Production no longer a central focus, but the plant should be the essence of what we do. And from a thematic approach, we should create a more integral approach. Risk management should shift to resilience at the end. And pest control, plague by plague, should be a completed systematic approach. And last but not least, where growers nowadays still depend on others, suppliers, which you see all over the place here at the Green Tech, growers should become more and more in lead. We see this shift is going on, and if it's to us, that should be speeded up. So again, from resilient, this is overall for what we call a resilient cultivation system, which needs in actual fact a complete new ecosystem as such.
Got it.
Thank you very much.
Thank you very, very much. Thank you. Yeah. Sort of a lovely congruence there, sort of a resilient plant and then a resilient system.
Exactly.
Sort of, so lovely. Thank you very, very much for being here, Professor. Edmund, if you could bring us a little bit more on the sort of commercial side of things, I suppose give us maybe some case studies as well. What do you see can be contributed from your angle into this dialogue on building, if we take Matthijs's sort of challenge, this resilient system that will, in a sort of utopian world, set us completely free from using chemicals. Floor is yours, sir.
Thank you.
They're getting it up for us now. While they do that, just a little reminder again for those of you who are trickling in later, please do not hesitate to shout out not loud right now, but later a question that you may have. We were looking for investors earlier. We've not seen them yet. But maybe there are some scientists here. I did not go into the education sector yet. I see a friend of mine who has revolutionized science. And so if you have any questions, please hold them for the end and we can work through them. Thank you, sir.
Thank you, Theo, and thank you, Esme and Matthijs, for your excellent presentation. And I fully agree in making your stories. So I want to take you into the data-driven approach. Let me first introduce to you quickly MPS. We are a foundation founded about 30 years ago by growers, for growers, to help them become more sustainable. And we have a number of data-driven sustainability solutions and a number of the more qualitative sustainability on both good agricultural practice and on social themes. A short introduction to MPS ABC, which is an environmental certificate. We ask growers to put in their data for over 30 years, for a lot of them. And it starts with crop protection agents, energy, fertilizer, water, waste, etc. And they use our data platform to register that on a daily basis. And after, let's say, a year, we do data analysis, we do a live audit, and we do a residue analysis of their crops. And if they comply to all the scheme requirements, they get a certificate and an MPS vignette, which was pretty much about it, and they could tell the traders and retailers, look, we are very sustainable. But we are, and by the way, we compare, benchmark these data to the growers in your own region, which are more or less the same crop. But we do more. And that's what I think is something, whatever you use, it is about, if you want to have a goal, which is residue-free crop, you need to know where you are. So we give back the data to the growers, where they are, but we also tell them the upper average and the lower average in their crop, in their region. So we tell them actually, how good are you performing? And then you can set, of course, your own goals. And we give pretty detailed information. We give colors to the crop protection agents, to the active ingredients. And we show also, in comparison with your other growers, how you perform. And the interesting part is that we also can show you how this is compared on a country level. So this is, for example, the situation in Denmark over the past years, from 2017 to 2022. And you see a 98 reduction over those 5 years in red crop protection agents, which is, of course, a huge decrease. I'm going a bit, some of my slides, they don't seem to come up. Sorry. Because maybe I can, what we also do, we compare and give insight, and that was a very nice sheet on growers with the same crop. And you see how many fertilizer or crop protection agent they use, and they all produce the same crop. They're in the same area, but they show a totally different use of crop protection agents. And then, of course, you can, together with other growers, decide, this is my goal. Where can we go? Where can we decrease in the number of agents used? And if you collect a lot of data, it is more easy to calculate your footprint. So a lot of the data we already collect for over 10 or 30 years, you can use to create the footprint calculator and to create this footprint of your organization. And also with FloriPEF CR, you get information on the dashboard, what are your hotspots as a grower. And it gives you the opportunity to calculate scenarios, to see where you currently are on crop protection agents. And if you reduce this crop protection agents or you change to another substrate, you can calculate the impact of your operation. So that's very nice insights, and you can adjust to the goal you want to reach. And from an example, we introduced MPS Greener Grown only this January. And actually, I won't go into the details, but actually it says you only can use EU bio crop protection agents. And what we saw in the pilot is that some growers who used crop protection agents until then, and they saw, I cannot use it if I want to have 1 star or 3 stars, and they stopped immediately. And I wonder, why did they use that orange crop protection agent until that point and are able to switch it off? So it's very interesting to see that if you set a goal together, or if you set a goal as your company, you can work to that goal and stop using some of the crop protection agents. And the other advantage of using data is that, for instance, for the CSRD, a lot of the information you already collect, you can use to create reports for your customers if they want to know, do you comply with the CSRD regulations. So actually, from my story, and sorry, some of the slides I missed, numbers tell the tale. It is, if you know what you're doing, you can set a goal and you can change and adjust your operation. And I think the roadmap of a residue-free crop is data-driven. Thank you.
Thank you. Thank you very much. Do you have any questions immediately? Anyone? I have a microphone I can bring over to you. Oops. I always wanted something to hang off from me. There's my moment.
Thank you, Theo.
Sure.
My question is for Koppert, actually. So you have this stated goal of reducing pesticide use, tenfold by 2030? And I'm wondering if you could quantitate that a bit in terms, are you talking about globally? Are you talking about locally in the Netherlands? And how does that fit with the goals of things like the farm to fork strategy?
Yeah, thanks for your question. And if I understood it correctly, you were asking whether I can elaborate on that decreasing tenfold coming 10 years. That's correct? It's a bit noisy, sorry up here. Yeah, we in actual fact, this goal was set already a couple of years ago. And we started measuring over the last, I think, 3 years or something by now. So what we did, without making it too detailed, we used the production schemes of key crops, like for example tomato here in the Netherlands, and based on what growers use on chemical pesticides on a regular scheme, we compared it with what if we replace this volume-wise by biologicals, and we did this for the main schemes for main crop for key crops, not all crops for which we provide biological control. And as a result, we could make a calculation. We call it the Koppert Sustainability Index, which shows real time, based on the volume that we sell, what we in actual fact replace. I had initially a screenshot in it, but due to time, I thought I had to take it out. Otherwise, I could have shown it.
Yeah.
I don't know whether people from Technique can show a hidden slide. I don't know whether they know. Well, I can't show it, sorry, but we haven't launched this yet externally. We show this internal, which is one-on-one, real-time replacement of chemical pesticides, key crop use, based on such a matrix. Does this provide an answer to your question? Thank you.
Great. Wonderful.
if I hear your story, then what about fungi? Because of course the most beneficials work for insects, right? Do you have also a plan for fungi
What do you
as
mean?
copper
Yeah, well,
to replace? Because it's much harder, I think.
yeah, well, what I try to explain briefly is what we are bit known, and our core products that we provide are macrobial, so the beneficial insects, next to that natural pollination, the bumblebees. But we are rapidly growing in microbials as well, and beneficial nematodes. So the microbials, it's a combination of the bacteria and fungicides, which we usually provide in a granular type of format. This is an application that we use more often. And here within Green Tech, we focus on controlled environmental agriculture, but we are also expanding in outdoor crops. And in outdoor crops, obviously, a number of beneficials are not feasible because they fly out or whatever they do. So we are more and more focusing on these solutions. And these solutions contribute from curative to preventative, because when growers sowing the seeds or the plants, whatever, we immediately add these granules to it, and as a result, the plant gets more resilient and needs, hopefully, and that's our aim, no medicines, read chemical treatment.
Thank you. So again, pointing to starting with a good plant. Is it something that you wanted to add on that, Esme?
I'm sorry, I don't hear you so well because
Sorry,
it's quite
yeah,
noisy.
I'm not so sure. Well, but starting with that good plant, as we mentioned earlier, as a preventative measure. Do you connect? Is there a connection between the kind of solutions that are provided in the space and starting well?
Yeah, starting material is really important
Yeah.
for the whole resilient cropping system. And starting with clean seed or already a resilient seedling or a strong plant from the beginning really helps through the whole cultivation to have this resilient cropping system. Yes.
Right. Is there another question? I'm always concerned about motivation, why people do what they do. I'm sure you have the same concern, not only for this particular topic, but in life generally. And so I'm always concerned, I mean, why is it, if there's such good data available, and it's evident that moving toward a sort of chemical-free solution is preferred, why is there not such a huge rush toward using a sort of chemical solution, a non-sort of chemical solutions for crop growth and protection? Where's the motivation coming from? Or what, let me put it this way, what should motivate growers?
What should motivate growers? Well, I think foremost important is that a grower is intrinsic motivated, that they want to leave this planet a better place. But looking at their operation, their business, of course, they want to make a good profit. They want to make beautiful plants and flowers and crops, and they want to produce enough. And so, what I experience, I'm only almost 2 years in this horticulture, and I think the demand is not there yet. I think at some point, of course, you can buy biological vegetables, etc. But if you look at the floriculture, it's all about beautiful plants and flowers, and not many consumers currently ask for more more sustainable flowers and plants. So that's a problem. And if the consumers are not asking, and the retailers and the traders are not paying a grower to put in this extra mile, he's probably not going to do it because, well, I think chemicals are pretty cheap compared to labor or mechanized input. So I think that's some of the issues. Yeah. Not enough demand currently,
Yeah.
which we should really try to promote. And I know a lot of growers who are intrinsic motivated to use no chemicals at all, but it's very difficult for them. Yeah.
In our
I would like to elaborate on that, if
Yes.
it's okay, because I think, to my feeling, the answer is pretty straightforward. Either intrinsic drive, economic reasons, or a certain urge. Intrinsic drive you already touched base on. We see it, for example, in floriculture in what the group called accelerators.
Yeah.
There's a group of growers who set targets and push us forward. And they say, we're not going to wait for legislation up until 2030. We set way more stiff targets. And that could be a mixture of these elements. That could be a first mover advantage, read economic reasons. But this is also partly an intrinsic drive. But don't underestimate, based again on the reports of the WER, for example, they know which products will be faded out. And they're not going to wait until the moment is there, and they're not going to wait till the urge is there. So to my feeling, these three pillars stand out in this.
So almost a combination of them, right? Sort of a combination of them.
Yeah.
But so you talk about a group, so this is not going to be a one individual effort, although when we were talking earlier, you had individual examples of growers who really are willing to bite the bullet, so to speak, and risk losing money, but preferably a group or cooperative where there's a collective movement. I don't want to put you on the spot, dearest grower, but does that resonate with you, the whole idea of needing to have a good sense of being motivated to modify the way you approach this particular issue? No, I'm going to give you a microphone so we can hear you. Be saluted, O grower.
I think motivation is definitely a big part of it. For me, I come from a aquaponic facility, and it's a very fast-moving crop. We have tried a lot of biological controls, but the main issue is it takes a bit of time to see the result. And when instead we could use, something like pyrethrins to combat aphids or something like that. So there is a motivation to look for a biological control, but there's also that motivation to protect your crop and protect your production. So,
Yeah.
yes.
Yeah.
Another question I just wanted to ask. I don't know if you want to give some feedback right away, because I have a follow-up. Please keep that microphone.
I think getting residual-free crops, it's, as we both said before, it's all about the prevention and preventative solution. And most chemical agents that we rely on now, they are mainly curative solutions. So preventive solutions, it will not lead to completely pest-free and disease-free plants. There will be some charges and balances that need to be found with high standards in production, but also getting plant resilience.
I was thinking about the motivation also for what I describe you as measuring your crop protection interventions. Do you have enough motivation, enough resources, or what would you need in order to more effectively sort of monitor and measure what happens? Because as you were pointing out, this measurement or monitoring of your crop protection interventions, you consider that to be absolutely vital for the grower, am I correct? But is that something that for you is important, the measuring of your interventions, and do you do that?
Yes, of course. I mean, when we try biological control, you do have to watch your crop very closely. Not only to see if what you're trying out is working, but the biological control you're using, but also that you're not losing too much production. You're not wasting time or money on something that might not end up working in the end. So I do think it's very important to focus on the curative versus preventative, and really work with companies like Coper and try to give data and information about whatever you try. so that you can work together to find a proper solution for your specific crop or your specific grow operation. I know ours is we're organic and aquaponic, so it's much different than the regular grow systems.
Yep.
So it's definitely really valuable to keep a close eye on everything and work with the companies to try and find a better solution.
Got it.
And do you also have the feeling that you can capitalize on the initiatives that you take?
I'm sorry, could you say that
Do
again?
you have the feeling that you can capitalize the investments that you make to reach out on this?
Yeah, I would say we definitely can. You said capitalize on.
Capitalize.
Yeah, well, when you invest in a complete biological control, it's a renewed way of working. It takes time, more efforts. Sometimes products are more expensive. Sometimes they're less. But anyway, you need another way of working. So
Yeah.
it needs time and effort, and at the end, money. And do you have the feeling that it's straightforward, that it pays off?
I guess it depends on the problem. A lot of the time, yes, it does pay off. And I think no matter what, it does pay off because you're gathering data and information that could be helpful to somebody else. There are definitely instances where we lose production. You know, we lose part of our operation where, you know, we could have gained that if we had, you know, stuck with a chemical pesticide or insecticide. But I think that's kind of just the old way of thinking and the easy option to go back to. But in the long run, I think we can capitalize, and it's if you looked at, you know, data from multiple grow operations, you would be able to easily see that you can capitalize off of that relationship.
Oh, that's wonderful. Be
Thank you very
saluted
much.
for that. That's commendable, absolutely. Thank you. Anybody else has got a question? You have a question. Let me bring over the microphone. I don't know. Can somebody shout to me? What time do we have left?
None.
All
Zero,
right, it's a
zero,
good
zero.
thing I asked. Trevor's got the speed clock on there today. So,
Hi, I'm Pooja. I'm actually Matthias' colleague at corporate,
okay.
and I'm originally from India, and I'm handling the market of India and Bangladesh and Sri Lanka. In terms of the motivation with the farmers, what I've seen in India, it's definitely there, and the demand is also there for consuming safer food, especially after COVID. You know, like a lot of Indians do want to consume safe, good quality food. Now, having said that, what happens typically in India is that, you know, when you are approaching these smallholder farmers, they are usually being accessed by distributor network. Now, the distributor network has not just corporate products. They have all the pesticides and fertilizers. So whichever will give them higher margin and the knowledge that they have, they're going to capitalize on that. So to reach to the smallholder farmer, a company like us have to make an extra effort to really motivate them, substantiate what we are saying with a lot of knowledge, with a lot of data, and that's in a lot of times, you know, we find that it comes as a challenge to us as well. And I feel like that's where we need to do an extra effort in terms of reaching out to these farmers.
Thank you very, very much. We've only scratched the surface here, but that's the best one can do in 45 minutes. Edmund, Matthijs, and Esme, thank you very, very much for joining us. Please share with me a moment of thanks to the. Thank you. Thank you for your time.